I am going to walk you through a suite of learning tools for general chemistry. The Lewis structure tool allows students to arrange atoms and electrons to show molecules. You can click and drag atoms to add them in the workspace, and then click and drag between them to form bonds. You can also repeat to form double and triple bonds. To add lone pairs, drag out from an atom and drop a smaller distance. There are additional features of the tool that help students in the learning progression. For instance, the electrons placed counter helps them keep track of the number of electrons added. You can also turn on the octet count and see how the number of electrons contributing to the octet of each atom changes as electrons are added or rearranged. Similarly, you can look at the formal charge of each atom. These are all features that can be turned on or off on the question creation side to tailor the tool to the specific question or learning objective. So for instance, for a question where it asks students to calculate the formal charge tracker would not be available for that question. All of these tools are accessible, so students can check their answer. The VSEPR tool allows students to build models in 3D by adding generic bonding groups and lone pairs. You'll notice that the interaction model for all of the tools is very similar to minimize the learning curve. This tool is in 3D, so you can rotate it around and add different groups to see the resultant geometry. The model data box is another feature that can be turned on or off depending on the question. This question is an example of one where the tool is not assessed. Rather, it is followed by a multiple choice question, and students can use the tool to help answer the question. With the hybridization tool, students can combine atomic orbitals to form hybrid orbitals. So here we can combine an s and a p and hybridize that and see the resultant sp hybrid orbitals. And this is also in 3D, so it can be rotated around. We can also build out and look at the adjacent atoms. So if I add in other atom centers, from there I can build those out. So we'll make some sp2s on the end here. Again, hybridize those and see the resultant geometry. We can rotate it around and see that it's planar. We can also move the atoms closer together and see the overlap to form the sigma bond. Similarly, on the other side, we can create sp2 hybrid orbitals. See the sigma bond, and then we can add in the other p orbitals and see the lateral overlap there and how the pi bond is formed. For this one, we'll have to rotate it to get the p orbitals in phase, and you can see how both pi bonds of CO2 are orthogonal to each other. The particulate reactions tool allows students to combine atoms to build molecules on each side of a reaction. This tool is great for helping students visualize a balanced reaction and connect the particulate view with the symbolic representation. You'll notice as I'm grouping the atoms together to form the molecules, the corresponding formula is updated in the equation bar. I can also type the formula here, click Update, and it will add the molecule for me. This one's really helpful for balancing because students can see there are 2 oxygens on the left and 3 on the right. So another oxygen is needed over here, but this also reinforces the concept that you have to add a whole molecule in order to balance because this now changes the chemical equation. So then I can add in a whole molecule and see how that changes the coefficient. Similarly, I can change the coefficient and update, and it will add another molecule for me, and I can see that it is now balanced. The equations tool starts to get into the symbolic tools where the previous that you saw were all particulate, including both 2D and 3D representations. This is an example of how they can use the periodic table and actually interact with it. So we're trying to find the atomic symbol for gold, so we can actually click on that, and again, check to see that it's correct. But the equations tool can also be used to write out chemical equations. You can use the buttons provided to create the equation, or you can type using the keyboard. This was designed with chemical equations in mind to make it easier and faster to type these out. So if I add a number after a letter, it automatically adds as a subscript, whereas if I put a number before a letter, it adds as a coefficient. Or I can press Ctrl to add superscripts. This tool makes it very quick and easy to type out chemical equations. The stoichiometry tool allows students to construct different conversion factors and build out the equation to convert units. The tool was designed to have a minimalistic interface to minimize distractions and help students focus on the task at hand. So it will auto-populate known or given values such as molar mass. So you can add moles over grams or grams over moles with the same label, and it will autofill the molar mass, and the units appear crossed out. You can also flip ratios. So if a student did this, they could look at the resulting answer and see that they have some weird units and think, maybe that's not right. These aren't crossing out. So I can select the whole ratio, flip it, and see that the units do cross out. We also have additional workspaces, so if you wanted to do this in separate steps opposed to all in one, you can do that by clicking and dragging the answer from one workspace into another. So then on this step, I could work on converting moles of HCl to moles of Cl2. You'll notice that the equation is part of what students can use to create the conversion factors. So they're understanding where these numbers come from, and now I can actually realize that this should be a 1 because Cl2 has a coefficient of 1. You can also increase or decrease the number of significant figures, and students need to recognize the correct value. All of these learning tools, and future ones, are designed to be accessible for all students, including those who are blind or have low vision.